The first thing you need to do is make sure that you have your flipped classroom paper out on your desk. If you don't have it, if you've misplaced it, the copy that was given to you in class, then you need to go to Edmodo and pull it off of Edmodo and either copy it down on a blank piece of paper, or if you have a printer, then you can print it. You can't go any further without that paper because that's what we're going to be checking. The second thing you need is a graphing calculator. It doesn't matter which model you have. My model is a little different. It has this crazy cool screen, but the steps I'm going to go through are for any model, so you need your graphing calculator. If at any point during this video you have a question or you aren't understanding something, you need to see it again, please press stop, press pause, go back, re-watch it again. That's why it's a video, so that you can watch it as much as you want, okay? So the first thing we all need to do is step number 1, which is reset our calculator, and we're going to do that by pressing second plus 7 1 2, second plus 7 1 2, and then you'll get a message on your screen that says that the RAM has been cleared. That sets everything back to a standard setting so that there's no interruptions. The second thing we need to do is to turn our stat plot on, and what this word stat plot means is that the data points we're actually going to plug into the calculator will then allow it to be graphed by our calculator, but our calculator will only graph those data points if our stat plot is on. So to do that, we're going to press the Y equals button, and then we're going to scroll up, as you can see, to highlight the plot 1. So we scroll up to highlight plot 1, and then we're going to press enter. And once you press enter, you should see that that plot 1 is now dark highlighted. So when you scroll down, it still stays highlighted. And on your screen, it might look something like this once you press the enter, okay? So the next thing we're going to talk about is what actually is a regression model. And regression is a vocabulary word that you need to know and understand. So what you're going to write down is what I'm about to say. A regression model is essentially a curve of best fit. A curve of best fit. In Algebra 1, you talked about lines of best fit for a set of coordinate points, and when you got your calculator to graph that set of coordinate points, then it would find the line that best fit those data points. Well, in Algebra 2, when we talk about regression models, it's not always a linear regression. It's not always a line of best fit. Sometimes it's a curve of best fit. And in this video, we're going to be talking about exponentials, so it's going to be an exponential regression that we're finding. Okay, so that's your definition for regression, is your curve of best fit. It's the curve or the line that best fits a set of data points. Now, I'm going to give you the x and y values. For our x values, we're going to use 1, 2, 3, 4, 5, and these will vary. They won't always be 1, 2, 3, 4, 5. It doesn't matter what the x values are. The y values that are given are 40, 75, 150, 297, and 510. So again, this is the data points that I'm giving you. If it were another problem, you may get these data points from the scenario or the situation. And what I'm going to do is we're going to take these data sets and we're going to find your exponential regression. So I'm going to demonstrate this in the calculator. You're going to write down the steps as I go through them on the calculator, and then I would suggest you stop the video, you rewind, and then you go back through the video again doing these steps on the calculator by yourself. Okay, so step 1, 2, finding exponential regression. Step number 1. You are going to press Stat. It's this button right here, right under the delete button. It brings you to a screen like this, and then you're going to press Enter to select Edit. And we are going to edit our list 1 and our list 2, and it's going to make it look just like this table. So your x values go in list 1 and your y values go in list 2. After every number that you enter, you have to press Enter. So in your x values, we're going to do the x values first. So in list 1, 1 enter, 2 enter, 3 enter, 4 enter, 5 enter. Make sure you press enter after every one. Scroll over to list 2, and now we're going to put in our y values into list 2. This is always the way it works, x in list 1 and y in list 2. So our y values are 40, 75, enter, 150, enter, 297, enter, and 510, enter. So that is your step 1 to finding exponential regression. You put your x values in list 1 and your y values in list 2. Then you're going to press Stat again, and this time we're going to scroll over right to the Calc. And at this point, I'm telling you that I want you to find an exponential regression, so we're going to scroll down to number 0, which is exponential regression. Now, if you notice maybe number 4, linreg, that's what you learned in Algebra 1. That's a linear regression. Quadreg is a quadratic regression. Cubic is a cubic regression, and you can go on and see all of the other different ones that they have. But we want exponential regression, which is number 0, and you're going to press Enter. Now, at this point, this is when it kind of matters what model calculator you have. So if you have either a TI-84 or a TI-84 Plus, then you will have the feature which I'm about to show you. If you don't have a TI-84 or a TI-84 Plus, or if your screen does not look like this right now, then one of these steps you're going to be able to skip, okay? And so I want you to see if on your screen you have Store Reg Ec. And what that means is store regression equation. So this calculator has the feature that allows the equation that the calculator comes up with, it can actually store it in y = for you. So to do that, we're going to press Enter all the way till we get to that store regression equation. And at that point, you're going to press alpha, which is the green button, and then trace. Alpha trace. And this should bring up a screen that says the y1, y2, etc. So if you don't have this store regression equation, then you're not going to have this feature in the calculator, and it's okay. You don't have to have it. You can still do the regression equation, but this is just an added feature. So then you're going to press Enter to select y1. So what that means is now the regression equation that your calculator is about to find is going to store it in y1. Okay, so again, if you don't have this feature, just ignore everything I said up to that point. You're just going to press Enter until it calculates the regression for you. And this is what your screen will look like once it comes up with the exponential regression. On your paper, you should be writing down your steps to finding exponential regression. And now you're at step 5, where you fill in what you see in the space here. So this is what your calculator screen should look like with the exponential regression. The calculator gives you the values for A and B that you use to plug into this equation. So the A value is 21.09080524, and the B value is as you see it here as well. So what this means, and this is really important for you to understand what the calculator is telling you. So if your A value is 21.0908, and we'll round that right there, 09081, and your B value is 1.909288, then you now use this information to write the regression model. And when you see that word model, I mean equation. A regression model is an equation for that curve of best fit. So the regression model for this data set would be y equals, okay, now I need the A value, which is this 21.09081. And now I need times B. So we're going to open my parentheses and plug in my B value, which was 1.909288. Okay, and then it says to the x power, so raised to the x power. And we know in an exponential function, it makes it exponential when the x is in the exponent. So this should make sense as an exponential function because your x is the exponent. Remember, we don't plug in any value for x when we're looking for a regression equation or just a general equation. Okay, so back to the calculator. If you had the model of a calculator that allowed you to do that store feature, if you now go to y equals, your equation will already be stored in there. If you do not have the equation stored in there, if you didn't have that feature in your calculator, then it would look like this. It would just be blank when you go to y equals. So at this point, I want you to enter in the regression equation, which is 21.09081. 09081, parentheses 1.909288, parentheses, to the x power. And remember, x is here right to the right of alpha. Okay, And now, remember our stat plot is on, so the very first step, we turn that on so that the calculator will graph those points. So if I press graph right now, the first thing that your calculator should graph is your regression equation, okay? And if you notice, there are no points, the actual data points that come up. So in order to see the data points that were in stat edit, that were in our list 1 and list 2, remember we have the data points here, we want to see those. So in order to see those, you press zoom, and then it's 9. Zoom 9 says zoom stat, so that's going to make your data points come up. So here we go, there's our data points that we have plotted. And now what the calculator is plotting is your actual regression equation. So it's that curve of best fit. So the reason why it's called a curve of best fit, or that's the definition, is because you can see the line goes through most of the points, but not exactly through all of them, but it best fits the data points that we have. So this equation that was created, this regression, exponential regression, is the best fit for the data points because, as you can see, it goes through some of them, not necessarily all of them. So that is how we use a regression equation or a regression function in our calculator to find the best model for a given set of data points. So at this point, you should go back, rewatch the video, make sure you can do all of those steps independently in the calculator.